Welcome to Vetrii NEET Gateway. So this is Anthony Raj, Chemistry faculty. Okay, you can watch this page for your chemistry videos, right? So today we will discuss about atoms and molecules. So today we know in chemistry about atoms. So much information is available, structure of the atoms, electrons, protons, neutrons, configuration, etc. But how do we arrive at here? Okay, how we have invented there is atom. Okay, so that introduction part only we are covering so in this video. Okay, how we arrived at knowing atom. Okay, yes, there is an atom, right? Okay, so that is what we are discussing today, right? So the idea of an atom is very ancient. Okay, Democritus, a Greek philosopher, okay, imagine that there is something called an atom. Okay, similarly, an Indian saint, Karna, so he also imagined that there is an atom. So what was their imagination? If you split the matter into smaller and smaller particles, ultimately there will be a smallest particle which is not divisible further. That is what they called as atom. Okay, so atom simply means indivisible in Greek language. Okay, so the same word is being used now also. So the indivisible smallest particle was called atom. It was only philosophical, not scientific research were done, but only in the end of 18th century, okay, again the research about atom was done. Okay, right? So then Antoine Lavoisier established two laws of chemical combination. So please understand that we are arriving here from the matter. So all material substances, all matter in the world is made up of basically atoms, okay, and their combination molecules or compounds, right? So from there only we are arriving at atom. Okay, Antoine Lavoisier, okay, great scientist, proposed two important laws of chemical combination which laid the foundation of the invention or discovery of an atom, right? Okay, the first law is law of conservation of mass. The second one is law of constant proportions. Okay, combinedly they are called law of chemical combination. That is how the atoms combine to get different molecules, right? Okay, here you must wonder, so what are these basic elements? Okay, how do they combine to become molecules? When they combine, okay, what kind of changes happen? For example, if you take water, which is a liquid, but the combining components H2 and O2 both are gases. So two gases combine, but the result is water liquid. Can you imagine that? Then take sodium chloride, where sodium is a soft metal, chlorine is a reddish orange gas. Okay, but they combine to give something like common salt. Okay, can you compare the properties of sodium chloride with sodium and chlorine? Okay, so something magical happens there when atoms combine. So what are these elements? How do they combine? And what happens when they combine? That is what we are going to discuss, right? Okay, so there are two important laws. The first one is law of conservation of mass. Okay, so that says the mass can neither be created nor be destroyed. Okay, so only one particular combination can be converted to another combination, right? So the mass cannot be newly created, or the mass which is available cannot be destroyed. I will take the example of this reaction, barium chloride and sodium sulfate, right? Okay, so before they combine, okay, so let's say this is sodium sulfate solution. Okay, so this one is sodium sulfate solution, let's say. So this is sodium sulfate solution, Na2SO4 solution. Okay, and in this small tube, say we take barium chloride, BaCl2, barium chloride solution, right? Now we combine these two, then we will get sodium chloride, okay, and barium sulfate precipitate, BaSO4 precipitate. Okay, so you can actually do this experiment, okay, in a conical flask, okay, close it airtight, because if there's some gases are formed, they should not escape. So we have to close this airtight and take these two solutions. So know the weight of barium chloride, sodium sulfate. So this is the weight before the reaction, right? Now you mix them both. You get sodium chloride, barium sulfate. Now the combination has changed, right? Okay, so sodium from sodium sulfate and chloride has combined to give sodium chloride, and barium sulfate we have obtained as a precipitate. Now after the reaction, now take the conical flask and take the weight. Okay, the weight before the reaction is equal to weight after the reaction. That simply says, okay, the mass cannot be created or destroyed. Okay, but you can clearly see a physical change in the reaction. Okay, so after a reaction, there will be precipitate and there will be different solution. The changes really happened, but the mass has not changed. That means that is conservation of mass. Okay, so the chemical combination happens, okay, at the level of atoms. That is where atoms become very, very important. Okay, the chemical reactions happen at the level of atoms. Only the combination becomes different. Okay, but the weight remains the same. Okay, you can clearly see that. So barium chloride BaCl2, sodium sulfate Na2SO4, right? So this Na and Cl2 has given NaCl, and barium sulfate has given barium sulfate. Okay, only the combinations have changed, but the mass has not changed. So it's very, very important development. Okay, very, very important law. Okay, towards the invention of atom, right? So mass can neither be created nor be destroyed. Only one form of a molecule can be converted to another form, right? Okay, now we will go to next, the law of constant proportion. So this is another important law, right? Okay, so say for example, you take carbon dioxide, okay, or preparation of water, right? Water can be got from different sources, right? Okay, and there are two different elements we know. One is hydrogen and one other is oxygen. So whatever be the source of this molecule, or whatever be the reaction by which water molecule is formed, okay, the ratio of the mass of two elements, hydrogen and oxygen, okay, the ratio of the elements, okay, right. So there are two atoms, H and O, okay, the ratio of mass of this element was found to be same, constant proportion. Okay, whatever be the source of water, whatever the reaction by which the water is got, okay, the ratio was same. Okay, now we know that for sure, but you think about this in the 18th, 19th century, right? So the ratio is 1:8. Similarly, if you take ammonia, ammonia has nitrogen and hydrogen, right? If you do, there are two elements, nitrogen and hydrogen. If you compare the mass, 14:3. Okay, this is the constant, right? So whatever the source of ammonia you get, or whatever the reaction you follow to prepare ammonia, the ratio remains same. It is another important development towards the discovery of atom. Okay, so the ratio remains same. There are two elements and their masses, the ratio of their masses remains same. So it is constant proportion. Okay, ratio of constant proportion. So these two important laws, okay, developed, okay, led to the invention of atoms. Okay, now look at this. So these are two important laws of chemical combination which led us to the invention of atom. Now we will try to understand what is an atom. So John Dalton was the first scientist. He proposed some important postulates about atoms. Okay, please remember in this lesson we are not discussing atomic structure. We are only discussing the basic properties of atoms. Okay, atomic structure we will cover in the next another video. Okay, here we are studying about some basic aspects of atoms. One is the atoms only participate in the chemical reactions, right? Not subatomic particles, okay, not molecules. Okay, the reactions happen at the atomic level. Okay, we have learned one example. Okay, sodium sulfate and barium chloride gives barium sulfate and sodium chloride. Okay, it happens at the level of atoms, very important. And atoms cannot be created or destroyed. We know all that already. Then a particular atom has the same mass, okay, and similar chemical property. If you take the chemical properties of chemical properties are decided at the level of atoms, right? At the level of atoms, the chemical property is decided, and they have a uniform mass. You take a particular atom, it has a particular mass. Oxygen 16, carbon 12, nitrogen 14. Okay, like that, for a particular atom, the mass is fixed, atomic mass. Then the chemical properties are decided at the level of atom. If you take an atom, it has similar chemical properties, right? So very, very important finding. Combined ratio of small whole numbers. We already learned that, right? Well, hydrogen and oxygen in water, 1:8, right? And in ammonia, 14:3. Okay, small whole numbers. Okay, I can give one more example. Carbon dioxide, 12:32. Or if you simplify, okay, which is 6:16 or 3:8. Carbon dioxide, carbon and oxygen in carbon dioxide. So this is nitrogen and hydrogen in ammonia. So this is hydrogen and oxygen in water. Okay, they combine in whole number ratios. Okay, so that is how we write the chemical formulae, right? NH3, H2O, CO2, there are no fractions, H2S and so on. Okay, right, and the relative number is constant in a particular compound. If you take a particular compound, the relative number is constant, Na2SO4, 2 sodium, 1 sulfur, 4 oxygen. Barium sulfate, 1 barium, 1 sulfur, 4 oxygen. Okay, sodium nitrate, 1 sodium, 1 nitrogen, 3 oxygen. Like that, the relative number is constant in a particular compound. These are some of the important postulates given by Dalton. What are the basic properties of atoms? Okay, so based on that only, now we are developing, okay, the chemistry about atoms. Okay, so John Dalton has given these important properties. So in this, the atom cannot be created or destroyed, which proves the conservation of mass, right? Then they are small, the ratio of small whole numbers. This confirms the law of constant proportions, right? Okay, and the last point is also very important. Any compound, okay, the relative number is whole number. Okay, it is not a fraction, right? So these are some important postulates given by Dalton about atoms. Okay, then listen. So importance of atom, okay, very, very important. So what we call as atom, okay, you cannot see that with your naked eyes, okay, you have to only imagine, because it's very, very small, very, 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 very small than you can imagine. You cannot even imagine the size, okay. If you take a thin paper which can have millions of atoms, can you imagine that, okay, 10 lakhs atoms in a simple thin paper, right, that is the size of atom, right. The size is around 10 power minus 9 meter. You have to really imagine this. Okay. So why atom is so important? Okay, right. So 1 nanometer is the size of the atom, which is 10 power minus 9 meters or 10 power minus 6 millimeters. Okay, 10 power minus 6 millimeters. So that is 1 divided by, okay, 10 lakhs millimeter. Can you imagine that? Okay, you take a small division of a scale, which is 1 millimeter, you divide that into 10 lakh parts and one part is atom. So that size we are discussing about, which the scientists could not have seen with naked eyes. Okay, only through research they have found out. Okay, it's very, very important. The thin paper can have 10 lakhs of atoms. Can you imagine that? So that is the kind of size we are talking about. Okay, at that size only they are indivisible. Okay, so which is 1 by 10 lakh times millimeter. Okay, that is very, very important. Okay, therefore, the hydrogen atom has around 10 power minus 10 meters. Maybe molecules have minus, okay, say 9 or minus 8 meters. Okay, which is very, very small. Okay, it is so small. Why are we so concerned about that? Because all matter, all substances, all molecules, all compounds, they are all made up of these tiny small atoms. And these tiny small atoms only participate in the chemical reactions. Okay, it affects the world every day. Okay, everything happens at the atomic level. So very, very important to know about the atoms. Okay, it follows that in periodic classification, we are going to learn about these atoms, their properties, their physical and chemical properties and so on. Right? Okay, so atoms are very, very important. Okay, so much of chemistry is involved about atoms. The chemistry is explained mainly based upon atoms. So very, very important, they affect everyday life. Right? Okay, so constantly affecting whatever we do. Okay, next we are coming to how to call this atom, how to indicate this atom. Right? We got to give a symbol. So initially some empirical symbols are given. Okay, some picturistic symbols are given. but now they are given an English letter. So CO is cobalt, Al is aluminium, Zn is zinc, Cl is chlorine. So you know many symbols like hydrogen H, okay, oxygen O, okay, calcium Ca, barium Ba. Okay, so we all know this. Then we have some Latin Greek basics that I'll cover next slide. Okay, then a few more examples I can give. We have copper, which is Cu, right? We have silver Ag, and so on. Okay, now they are given English symbols. Okay, one letter or two letters. First letter will be always a capital letter, and the second letter will be a small letter. Okay, like that the symbols are given for every atom. Because we are going to study about these atoms, we are going to study about the reactions of these atoms. Okay, in all those places we have to indicate the symbols only. We are going to write chemical equations, so we will have to use symbols only. The symbols are given to IUPAC. Now you must know about this IUPAC. IUPAC is International Union for Pure and Applied Chemistry, right? Okay, that decides what symbol has to be given. Okay, the symbols are already given. There are about 180 elements. The symbols are given for every element. Okay, and we are using that every day, right? Okay, so the atoms are very important. Now they are given symbols. You can directly use the symbols in the chemistry what you study in the reactions, right? Okay, some names are from Latin and Greek. Okay, for example, so iron, IR should be there, but the symbol for iron is not IR. Okay, so it is Fe, because in Latin it is called ferrum. Okay, so therefore it is Fe. And sodium is to be SO, right, or SD, which is not so, which is Na, because in Latin it is natrium, right? Potassium, it is not P or PO. Okay, actually PO is polonium, P is phosphorus. For potassium it is K, because it is called kalium in Latin and Greek. And for gold it is auric, Au, right? So okay, for silver it is Ag, right? So some letters are from Greek and Latin. You need not remember everything at one go, right? You keep using that, like you know H2O, like you know carbon dioxide. Okay, so one day you will definitely know, like you know chlorine, Cl. Okay, like you know oxygen, it comes automatically. Okay, you just go through these symbols once in a while, and you will get used to that. Okay, so argento, which is Ag, auric, which is Au, okay, and so on. So some symbols are given in Latin and Greek, right? Okay, so you will get used to this over a period of time. Okay, right. So now I want to introduce to you the atomic mass. Okay, so very important revelations were got from the mass only. Conservation of mass and the mass rates of elements. Okay, from that only we have decided about atom. So atom has a specific atomic mass, okay, and has similar chemical properties, right? So atom has a definite mass, right? But you know the atom is so very small, the size is in nanometers, so the mass will be very small, right? Okay, it is in the range of 10 power minus 27, 10 power minus 25. Okay, therefore we cannot write that value every time. Therefore they have arrived at something called atomic mass unit. Okay, like you have unit grams, ml, okay, like you have kg, seconds, like that. AMU is a basic unit. What is this AMU? AMU is basically, we can say, which is the mass of one hydrogen atom. Okay, we can say mass of one hydrogen atom. Okay, hydrogen atom. Okay, which is only one proton. Okay, or oxygen also was used. 1/16 of, okay, the atomic mass of oxygen. We all know that the atomic mass of oxygen is 16, right? 1/16 means, again it simply means atomic mass unit. Okay, like mass of one hydrogen atom. Now actually why oxygen was used? Oxygen was used because, okay, there are so many compounds which are oxides. Okay, oxygen is one of the most prominent element in nature. Okay, abundantly available. Okay, so much of compounds are oxides only, right? That is why it was used. Now they are using carbon 12. What is carbon 12? Which is the isotope of carbon. Carbon has 2-3 isotopes. Okay, carbon 12. 1/12 of carbon 12. Again, it is almost equivalent to mass of one hydrogen atom. Right? Okay. So therefore, these are the basic atomic mass units. Okay, what happens when you divide the atomic mass of a particular atom divided by its atomic mass unit? Okay, you get a whole number. Okay, that number only you are using as atomic mass. okay, or unified atomic mass, which can be called AMU or U, which can be called AMU or U. So, which can be used in all our calculations. Okay, we are dividing that by a basic unit, which is equivalent to, we can say it's approximately equivalent to mass of one hydrogen atom, okay, which is now 1/12 of carbon 12 atom, right? That is called relative atomic mass. The relative atomic mass only we are using in our calculation, because the mass values of these atoms are very, very small, okay, in the range of 10 power minus 27, 10 power minus 25. So we are using the relative atomic mass only in our calculations. Okay, in today's class, we have covered about the atoms. Okay, how we arrived at the concept of atom, what are the basic properties of atoms, how the symbols are given, okay, and what is atomic mass, what is atomic mass units, okay, and how are you going to use the symbols and laws of chemical combination. So this is about atoms. In the next video, we are going to study about the molecules, how these molecules combine to form, how these atoms combine to form molecules. So that part we will cover in the next video, second part of atoms and molecules. Today, so we have seen enough information about atoms and the discovery of atoms. Next class, we will discuss about the combination of atoms for the formation of molecules. Okay, so you can watch this space for your chemistry videos. Okay, regularly we will be posting videos, okay, in chemistry. Okay, second part we will discuss about molecules in the next video. Okay, thank you.